Most people think fields, like the electric field, magnetic field, or even gravity, are invisible forces floating through space. But what if I told you that's wrong? And not just a little wrong, but like really, really wrong. Today we're going to tackle the biggest misconception about fields and explain it in the way quantum physicists see them. Traditionally, in high school physics, fields are presented as arrows in space. You're taught that an electric field pushes a charged particle or that gravity pulls an apple down. That image makes sense, but it can lead you to think that fields are actually stuff, like a fluid or a force cloud floating around. But they're really not. In quantum physics, fields are actually the fundamental reality. Now, what do we mean? Every particle you've ever seen, from electrons to photons, is actually an excitation of a quantum field. Imagine the electron field as a calm, invisible ocean. An electron isn't a ball sitting on top of the field. It's a ripple in that ocean. The field itself exists everywhere, whether or not there is a particle moving through it. The field is omniscient and exists everywhere and every time. Think of it like this. The Higgs field is a quantum field spread throughout the entire universe. Particles interact with it, and that interaction gives them mass. Without it, everything would be massless and zip around at the speed of light. The field is invisible, pervasive, and completely real, but it's not really matter in the traditional sense. Particles pop out of it like waves rising in the ocean. But this idea isn't just philosophical. It can make modern physics sound weird or magical. When you understand fields as a background fabric that allows particles to exist and interact, suddenly quantum mechanics, particle physics, and even cosmology start to make intuitive sense. Forces aren't pushing things, they're manifestations of underlying field interactions. Take light. A photon isn't a tiny bullet traveling through space. It's an excitation of the electromagnetic field. When you flip on a light switch, you're not filling a vacuum with invisible force, you're triggering ripples in the electromagnetic field. And when two electrons repel each other, they do it by exchanging these virtual photons, which are disturbances in that same field. It's elegant, weird, and beautiful. So the next time you hear someone say, fields push and pull things, remember that that's just a simplification and doesn't explain the bigger picture. Fields aren't things. There's a stage on which particles dance. The real magic of quantum physics is seeing how these fields interact, creating the particles, forces, and matter that make up everything you know. If you want to go deeper, check out how quantum field theory predicts particles popping out of the vacuum itself. It's pretty mind-blowing. And that's the power of understanding fields the right way. If you guys enjoyed this video, make sure to like and subscribe. Be curious like a child, the world needs more of it. Bye!